Today I'm gonna talk about the derivative of composite function, the application of chain rules twice. We're still gonna focus on the trig function and general power rule. Let's take a look at the first formula, that is general power rule. The derivative of fx to the power n equals n times fx to the power n minus 1 times the derivative of fx. The second formula is a typical chain rule. The derivative of capital F little fx equals the derivative of capital F fx times the derivative of little fx. Okay, and here the capital F can be any trig function. For instance, if capital F is sine, then the derivative of capital F gonna be cosine. If capital F is cosine, the derivative of capital F should be negative sine. If capital F is tangent, then the derivative of capital F should be secant square. And the third one is power rule. Okay, the special case is the derivative of x, that is 1. And the fourth one is the constant multiple rule. I also list derivatives for 3 trig functions. Now let's take a look the first example. For the first example, tangent to x squared, we can tell what is the fx. That is tangent to x. Okay, so it should be a capital that is fx squared. We're gonna follow this general power rule. So we have n is 2 tangent to x to the power n minus 1, 2 minus 1, and times the derivative of fx. fx is tangent to x. Okay, now we can simplify it. We have 2 tangent to x, and for this guy we can tell what is capital F according to this chain rule. Capital F is tangent. What is fx? Fx is 2x. So that means fx is 2x. So that means what? The derivative of capital F gonna be secant square. So we have secant square fx is 2x and times the derivative of fx. Okay, and we copy the first 2 terms. 2 times tangent 2x secant 2x square. And how to solve the derivative of 2x? We're gonna apply the constant multiple rule. That means what? That means we're gonna keep a constant 2 the same, or pull the 2 out of the derivative. We only do the derivative for the x. Derivative of x equals 1. So 2 times 1 is 2. So we're gonna have 2 times 2 is 4. So we have 4 tangent 2x secant 2x square. Okay, now let's take a look the second example. For the second example, we can easily tell what is fx. What is fx? Fx is this guy. So we can write down as fx equals 1 minus sine 3x squared plus 2x. Okay, so we're gonna follow the general power rule. N is 3. Fx to the power n minus 1 gonna be 1 minus sine 3x squared plus 2x. 3 minus 1 times the derivative of fx. Okay, and here the derivative of the difference of two functions gonna be the derivative of each function. Okay, so we can simplify this guy. Derivative for each function. Okay, now let's take a look. The first term. The first term is the derivative of 1. Derivative of constant that equals 0. Okay, now we can continue to simplify. And for the second term, derivative of sine 3x squared plus 2x, we can follow this chain rule. What is capital F? Capital F is sine. What is little fx? That is 3x squared plus 2x. So little fx equals 3x squared plus 2x. Okay, and we can simplify this guy. Since here is 0, 0 minus becomes negative, right? It's a negative of this guy. So negative, put a negative here, we have negative 3, 1 minus sine 3x squared plus 2x squared. And here, we're gonna apply the chain rule. Derivative of sine gonna be cosine. Cosine fx is here. 3x squared plus 2x, and the derivative of fx. So we have this guy. Okay, and now for the last term is the derivative of the sum of two functions, gonna be the derivative of each function. So we can write down like that. Copy all the three terms. We have cosine 3x squared plus 2x. And for last term, we're gonna do the derivative for each term. Okay, and here we can apply the constant multiple rule again. We can have what? Keep the 3 out of the derivative, and here is 2. We can keep the 2 out of the derivative. Gonna be a derivative of x. So we can copy again. Negative 3, 1 minus sine 3x squared plus 2x squared cosine 3x squared plus 2x. And here we're gonna apply the power rule. So 3 times x to the power 3 times 2 x to the power 2 minus 1 plus 2 times x to the prime. Okay, x prime should be 1, so 2 times 1. And now we're gonna simplify all of them. Negative 3, 1 minus sine 3x squared plus 2x times cosine 3x squared plus 2x, and the last term is 6x plus 2. Okay. Now let's take a look the last one. For the last one, we have the rational expression, and how to convert this guy to the general power rule format. As we know, there is a famous formula that is 1 over a to the power n equals a to the power negative n. Okay, here a is the whole stuff here. Right, 1 minus tangent of 5x plus 1, n is 2. So we can simplify this guy as here. We can write down as 1 minus tangent 5x plus 1 to the power negative 2, and then we do the derivative for this guy. Okay, now we can easily find what is fx. Is this guy. That should be fx equals 1 minus tangent 5x plus 1. Okay, tangent of 5x minus plus 1. Okay, now we're gonna follow this rule. What is n? N is negative 2. Okay, and times fx 1 minus tangent 5x plus 1 to the power negative 2 minus 1. Okay, times the derivative of fx. Okay, now we're gonna do the derivative of the difference of two functions. That means we're gonna do the derivative for each term. Okay, so let's simplify all this term. And we're gonna do the derivative for each term. And we can tell for the first function, derivative of 1 equals 0. And for the second term, we can use this chain rule. Here, what is capital F? Capital F is tangent. What is letter fx? Letter fx is 5x plus 1. So 5x plus 1. So fx equals 5x plus 1. Okay, so we can plug in negative 2. Here's a negative, so we have positive 2. So we have 1 minus tangent 5x plus 1 to the power negative 3, and the tangent, derivative of tangent should be a secant square. Fx should be 5x plus 1, and times the derivative of 5x plus 1. And for the last term, again, we can see here the derivative of the sum of two functions gonna be the derivative for each function. So we can simplify again. We have derivative of 5x, derivative of 1. And for the first term, we're gonna apply the constant multiple rule. So it should be 5 times x prime. And for the second term should be 0 because the derivative of constant. Okay. And again, the derivative of x equals 1. 1 times 5 equals 5. So 5 plus 0 is 5. So the final result should be 2 times 5 equals 10. So 10. 1 minus tangent 5x plus 1 to the power -3 secant 5x plus 1 square.